So welcome to that HPE Dev Munch Learn. This is our fourth sessions. We run those Munch Learns every month and toward the end of the month on Wednesdays. And today we're going to talk about building a foundation for zero trust with Spiffy. And we have Daniel from HPE. Before you get the floor, I wanted to share a couple of housekeeping items. We maintain the calendar for those Munch Learns on this URL. We will type all this URL in the chat, so you can open that chat window and get the links from there. On that page, you'll find the calendar for all the events, the registration link, and once it's available, the replay for the past sessions. Our next session will be the part 2 of a session we ran in last month, which was called Data Science Unplugged from Doug Cackett. And this was a really nice session using a whiteboard discussion, basically run by Doug and with Ellen Friedman as a master of ceremony. So if you attended the part 1, feel free to join. If you missed part 1, you can find the replay in that link at the top of the page, and you can join us for part 2. There will be no session in June. I said that, but maybe there will be one after Discover. If I can manage that, we are looking at maybe something in June. But the week before last in June will be HPE Discover. That's a big thing, and we'd like to avoid conflict there. As I said, this is called Munch and Learn because initially we wanted to call this Lunch and Learn, but because we don't know what time it is in your location and we have people joining from all over the world, we call this Munch, and it's okay to have a snack with anything you like. But if you want to play the game and participate, we have set up a Slack channel in our workspace dedicated to Munch and Learn. So I know Frederick already shared his pancake, and that looked really, really good. If you want to upload your munchie and share with us what it is that you're doing or you're having with your Munch and Learn, be happy to. Otherwise, you can also share it on Twitter. If you do so, use the tag HPE Dev so we can find it. And so thanks for sharing things on those munchie channels. And with that, I would like to get started and hand over to Daniel. If you could just quickly present yourself. Thanks. Thank you.
Hi, thank you so much, Didier. So I'm actually going to be getting started.
Okay.
Let me just share my screen. All right, so as Didier said, my name's Daniel Feldman. I'm with HPE. I work in the security engineering group. So here's our agenda for today. This is sort of what we're going to be talking about. First of all, I'm going to be introducing the general problems that we're solving with Spiffy and Spire and network service mesh. Then I'll be doing a brief introduction to how this technology works, a little bit more detail about the architecture. So back before cloud was invented, not too long ago, your company had a bunch of internal servers, maybe made by a company like HPE. They're running on bare metal or on VMs, and they're inside your company's firewall. They're inside your data center, and you trust that you have perimeter security around that data center. And then you have a DMZ, which is a select few servers that are allowed to talk outside the firewall. And then in the new world with the cloud, there's a lot more data centers. You may have many different data centers within your organization because you're running a lot more services. You're running a lot more services because there's more stuff to do. There's more internet-facing projects. You may have multiple clouds or multiple regions within one cloud. So AWS East Coast region is effectively a different cloud from AWS West Coast region. And you're establishing all these very specific network links between these services. And you have a lot of network links to manage, a lot of potential traffic flows. And if any one of these services gets compromised, it could potentially compromise any one of these other services, or even things that are outside your perimeter, like managed databases or partner networks. So what Spire does is it generates unique, secure, and cryptographically provable identities and gives them to all your services. So then they can verify communication with each other directly using those identities. So here's a really brief history of what we're talking about. So first of all, on the right, Spiffy is an open source standard for distributing service identities, and then Spire is the implementation of that standard. And the reason for differentiating is because, of course, in the future, there might be different implementations of Spiffy, and there already are to some extent, but they're not really complete yet, but they're going in that direction. In the future, we're hoping that there will be a wide variety of different implementations of Spiffy, and you'll be able to choose the one that makes sense for different applications. But then Spire is the one that we actually maintain. And sort of this basic technology goes back quite a ways. None of this is really new, but companies like Netflix and Google have had some kind of service identity layer as part of their infrastructure going back to 2010, 2014 for Netflix. They've talked about this publicly. There hasn't been a widely accepted open source way to do service identity until relatively recently. And now a number of other companies are adopting the technology. HPE acquired Sitel, which is the company I worked for, just about 1 year ago. And Sitel had a number of the developers on Spiffy and Spire. Are there any questions so far? I know that was a lot to cover. Okay, so I'm going to talk very briefly about the key benefits of Spiffy and Spire. And the reason I'm going to talk about the benefits first is because then we can get into the architectural details and how you might actually apply this in an organization. So first of all, I've already talked about this a little bit, but Spire gives you defense in depth. So if you have one service and that service is compromised, it can't talk to just anything on your infrastructure. So this is a really useful security property that security teams are always looking for in order to defend organizations. Reduce security overhead. So remember, we had all these network links connecting different services on your cloud and your on-prem infrastructure. Spire can manage those automatically. You give it policies, and it automatically manages those identities. So you don't have to have a security team that is sort of in this critical role, constantly creating authorized traffic flows. And then last, this is something that a lot of our users are really interested in. They actually don't really care about security. What they care about is they have a ton of services and they've lost track of who's talking to who. They don't want to have someone spend 6 months auditing their infrastructure and making a giant Excel spreadsheet of which services talk to which other services. So they actually just want Spire essentially as a service identity so that they can gain more observability and logging into their own network and for auditing and that sort of purpose. And they actually don't need the identities to be secure. But this is a pattern we see a lot in many different organizations. Okay, so zero trust. The term zero trust is really interesting. It started out with a very specific meaning. Today, basically every vendor and every company says it has some version of zero trust. So I like to define zero trust before I use it because everyone uses this terminology, but they all use it with slightly different meanings. But the basic backstory is that there were a number of attacks and continue to be a number of attacks where a hacker gets into a weak part of someone's infrastructure, and then from there uses that as a jumping off point to attack other parts of that infrastructure. So these ones are a little bit funny examples. Target stores, someone hacked in through the HVAC system, and in a casino, this was a couple years ago, someone hacked in through a connected fish tank, actually, that was in the casino. So those are a little bit of funny, memorable examples, but obviously there's all kinds of services that are maybe not fish tanks, but are still weak, that have access to way more than they should. There's also this case, this is not a super funny example, but there were hackers believed to be from China who managed to breach essentially all of Google's network, breaking in through weak services, and then attacking a variety of infrastructure within Google. This was way back in 2013, and this case actually motivated a lot of the work on zero trust at a number of different companies, because they said, how do we prevent this from happening in the future? This is huge. They're accessing all kinds of private emails and data from thousands of different companies. How do we prevent that from ever happening again? So this is a good quote from a leader at the NSA who would know more about hacking networks than anyone. Once you get in through the castle wall at an organization, you can pretty much migrate to different services within that organization. Now this is.
There's a question in the chat, sorry to interrupt you, from Eric. There seems to be some overlap between this and service mesh. So how does this compare with service mesh?
Oh, what a good question. So I actually work on service mesh as well. So I'm pretty familiar with that. The service meshes, depending on which one you choose, do establish secure relationships between your services. And that's one approach you can use to achieving a zero trust architecture. It depends how secure access to your service mesh is. If anyone can launch anything in your service mesh, if I'm an attacker and I can launch a bad service in your service mesh, and that service gets a secure identity, obviously then the service mesh isn't really helping with security. But if you're limiting access to the service mesh and providing policies for which services can talk to which other services, then that can help you achieve a zero trust architecture. Did that answer the question, Eric?
Yes, it did, actually.
All right.
Thanks a lot.
Good. So that's one tool you can use in the toolbox. And Spire is a somewhat different tool, and then NSM is, again, a somewhat different tool. So this is actually the official US government definition of zero trust architecture. This is from NIST. I like to put this in the presentation because it's an official definition, so you can't argue with it. Or at least not as many people can argue with it. But there's no implicit trust granted to systems based on their physical or network location. So whether your service is running in a particular cloud or a particular cloud account, or a particular region within one cloud, or a particular data center doesn't grant it any specific permission to access other services. And you can find this document easily if you search for NIST zero trust definition, and it goes into a lot of detail about exactly what that means. Then every vendor in the business is claiming that they support some kind of zero trust architecture, and that's why I like to stick to a solid definition of what a zero trust architecture is, so that we can demonstrate that our tools help you achieve that.
There's another question, if you don't mind. How can we apply the same paradigm to data mesh and federated data access?
Oh, well, for data access, I've seen the presentations on the data mesh concept. It seems to me that that's a bunch of services that are also communicating in order to provide access to data. If each one of those services has its own unique secure identity, then that could help you achieve a zero trust architecture. I hope that answered the question. It just seems like a different application of the same ideas. Although I don't know if we've tried that yet.
Okay, I think it did. For people who are asking questions in the chat, so whenever Daniel is asking you whether it actually answered your question, please make sure to use the reaction button and use the thumbs up if you're fine with the answer. That will prevent me from waiting for your answer, and that will ease the process, I would say. So thanks a lot. You can go on, sorry.
Right. Thanks, Didier. Okay, so we just went through like literally the official government definition of zero trust, and this is a little bit theoretical, but I like to stick to really specific, clear examples. So this is what I'm going to call the motivating example for what we're doing. And there are many other different things you can do with Spiffy and Spire, but it's good to stick to one concrete example. And this concrete example is, how do we connect a web app to an on-prem database? So we've got a web app, it's running in Kubernetes on a cloud provider because it's a very common architecture. And for some reason, it has to connect to an on-prem database. Maybe this is a online store and it has to connect to an inventory system that's running in an on-prem database. Very common problem. It's something that people have a variety of different approaches for solving already. So today, the most common approach for solving this would be that you would have a site-to-site VPN going from your on-prem data center to your cloud provider account. And Amazon makes this really easy to set up. And there's only one problem with that, which is that if your web app is ever compromised, it can attack all kinds of different things in your on-prem data center. Maybe even getting into your corporate network, stealing your confidential customer data, that kind of thing. So then we can look at different approaches that solve that problem and prevent this web app, if it's compromised, from being able to attack different things within your infrastructure. So again, definition, there's no implicit trust granted based on physical or network location. So here, the web app has implicit trust from its network location in a cloud provider, and we don't want that. TLS tunnel. So that's one approach to solving this problem.
Daniel, we lost you for a few seconds. Can you just repeat the last
sentence?
Sorry
about that.
That's okay.
So Spiffy can grant secure identities for TLS tunnel. So that's one approach to solving this problem with Spiffy. Another approach is if your application identity supports X509 certificates or JOTs, then you can use the Spiffy identity directly in the application protocol. So that's another way to establish a secure relationship from the web app to the database. And then once I'm done talking about Spiffy and Spire, Frederick will be getting into network service mesh, and that's at a lower level. That's at layer 3, or it can even operate at layer 2. And there's some reasons you might want to do layer 2, which I'm sure he'll get into. So this will be the motivating example to keep in your mind as we're talking about how Spiffy and Spire work. So remember, Spiffy is the standard for establishing a service identity. So I'm just going to talk about the standard for a minute, and then we'll get into the specifics of the implementation of that standard. So the standard gives you a standard format for a service identifier. This is just a text string. This is pretty easy to understand. It just we're specifying that each service consists of a trust domain and a service name. And the trust domain is just a name for your organization. And then the service name is a name for a service within that organization. Okay, now this is where it gets a little bit more complicated. The standard specifies a Spiffy verifiable identity document, which is a cryptographically verifiable document that asserts a specific Spiffy ID. So this is a lot of words. What this means is it's an X509 certificate or a JavaScript web token. It can be either one. And in either case, it's signed by the Spiffy provider, and it indicates that this service has this Spiffy ID. And again, a Spiffy ID is just a simple text string like that. Then the standard specifies how to distribute what we call trust bundles, which are the keys that you need to verify SVID. So this is just like the certificate bundle that you might have in your server or in your web browser in order to verify certificates already. And then finally, there's what we call the workload API. And this is an API that allows a workload to retrieve its current Spiffy ID, its SVIDs, and its trust bundles. So why do we need an API to do this? Well, your Spiffy ID, that's defined by policy, so that could change at any time. Same with your Spiffy verifiable identity document. These things have a short lifetime. They're not designed to last for a year or 2 years like a normal web certificate. And then also the trust bundle can constantly be changing as you're adding new services, adding new relationships between Spiffy providers. these public keys are rotating because they expired. So you need an API to be able to retrieve this from the workload. And the Spiffy standard includes the standard for how to deliver all that information. Does that make sense so far? It's a lot of information to cover. But each one of these is covered in a document on the Spiffy website that's been debated and agreed to by a number of different organizations as the right way to deliver workload identity.
Daniel, there were two questions. So first one from Meg, asking, when I think of security, Java doesn't come up of mind, quite the opposite anyhow. How does Spiffy make sure Java is legit? That's the first question.
Oh, okay. So I didn't mention Java specifically, but we do support Java. So we have an implementation of the workload API for Java. So your Java application can then read its Spiffy ID, SVID, and trust bundle. And it's actually even better than that because if you look at enterprise Java, it has a way to specify arbitrary certificates, and our implementation can feed in the SVIDs directly into that Java networking layer. So you don't actually even have to modify your application to specifically read SVIDs. So we actually integrate really well with Java. Okay. Whether other parts of Java are secure, that's up to you. I'm sure it can be made secure, but it certainly had a lot of vulnerabilities in the past.
Okay, the second question was about the SVID. Is it based on W3C verifiable credentials model?
I'm not familiar with the W3C verifiable credentials model, so I'll have to look that up. It does use a standard format called JWKS, which is, it's definitely in RFC. I don't think it's a W3C standard.
Okay, and there's one more question.
A quick note on that. Spiffy predates the W3C verifiable credentials, so it's almost certainly not based on it.
Okay.
Oh, thanks, Frederick. I'll have to look into that. I haven't looked at that standard.
And one additional question from Alex saying, can you say a bit more about what is in the trust bundle? For example, can the trust bundle be sold as of a manifest that attests to the security of the platform on which the service is running?
Oh, that's a great question. So the trust bundle does not include that information specifically. All the trust bundle includes is everything you need to verify an SVID. Now, we've specified, we've written this Spiffy standard. This doesn't actually say anything about these identities being delivered securely. So you could, at least theoretically, have a Spiffy implementation that doesn't make any assertions about the underlying platform or the software that's running on it. That wouldn't be very useful. But that's getting into the difference between the specification and then the implementation of that specification. So when we get into Spire, which is, again, the implementation of Spiffy, that is making assertions about the security of what's running on the platform. But Spiffy itself, you could write a garbage implementation of Spiffy that would meet the requirements of the standard that wouldn't actually do anything.
Okay. And one last question, then I'll be handed over to you finally.
Okay.
How key management is actually done? Does this depend on traditional KMS, or is there some distributed key management?
Oh, wow, that's a really good question. The key management is actually done in a plugin interface within Spire. So again, we don't actually specify how to do it as part of Spiffy, but in Spire, there's a plugin that can manage keys using a variety of different, well, there are different available plugins, and we're working on more. So actually, just in the latest release of Spire, there's support for AWS key management service, which then provides a bunch of additional security guarantees on where those keys are stored and who can access them at the AWS level.
Okay. And as you can never trust a French guy, there's always one more question. I'm very sorry for you. Does the SVID carry the RBAC permission, meaning the role-based access permission?
Yeah. So that's not in the SVID. That's implementable at a higher level once you have the SVID, and we can show how to do that at the end. Yes, it's authentication only.
Okay.
So here's sort of a very high level overview of how Spire might work in your organization. You might have some stuff on a cluster, some different nodes. Each node in a cluster or each virtual machine will have a Spire agent, and all of those Spire agents are talking to a Spire server constantly. Now, the Spire agent is responsible for verifying the identity of the service and distributing the SVID. All the SVIDs are generated and signed at the Spire server. So you keep the Spire server very safe in your infrastructure, either a really locked down AWS account, or if you're on-prem, a really locked down server that very few people have access to, because it's generating all the SVIDs. The agent is responsible for distributing the right SVID to the right application. So then I'm just going to do a very, very quick overview of how Spire actually is doing this distribution. Okay, so again, we've got agents, we've got workloads running on nodes, running on the cloud or on Kubernetes. The first step is the Spire agent needs to prove its identity to the Spire server. So this is actually, in some ways, this is the most complicated part of Spire, because the agent is getting some information. Maybe if it's running on Amazon Web Services, it's getting that information from the instance identity document. If it's running in Kubernetes, it's getting it from the service account token, and it's providing that to the Spire server, and the Spire server is performing some kind of verification process that proves that the Spire agent is who it says it is. And then in workload attestation, the agent checks the identity of the workload. And this is, in some ways, this is a lot simpler because if it has a process ID, it can find the binary of that process. If it's running in Kubernetes, it can find the pod and find the service account that it's running under. There's actually a lot less flexibility for how the workload attestation part works. Okay, and then you have to do this at least twice. You have to do this for at least 2 different workloads. And then once they both have identities, they can establish secure communication.
How does HPE Aurora project integrate with Spire? Is it just a plugin that provides most stuff to the base agent of the authentication onto, or not?
Yeah. So Aurora is a long-term vision for HPE as a company. I don't know how much of it is public yet, but the goal is to be providing this kind of Spire-like security between built into HPE servers. So if we back up and go to the node attestation, this node attestation step, in addition to being able to talk to Amazon Web Services or Azure or Kubernetes or Google Cloud, it would also be talking to HPE hardware like ILO and generating these identities in a way that works particularly well with HPE hardware. But it will still continue to work with all this other stuff too. Does that answer the question?
Yes.
Okay. Okay.
There are plenty of questions. I'm very sorry. What is the process of migration from an environment to another environment, like dev to staging or SAG prod, and the security update of the Spire agent and the Spire server?
Oh, I mean, that's a really detailed question about how to implement this. I would try to keep the same configuration in dev and stage and prod if it was my choice, and then that way if you know something works in dev and stage, then it will work in prod. Otherwise, if you have configuration differences, you could end up with problems. You don't want your dev environment to be able to talk to your prod environment, though. So you can configure that at the Spire level. If they're 2 different Spire servers and they don't connect in any way, they won't be able to talk to each other.
Okay.
So I'm actually going to skip this. This is a little bit about the internal architecture. All this is trying to say is every component of Spire is pluggable. So you can replace the upstream certificate authority. You can replace the key manager, like I said before. You can replace how node attestation works. Like you could write something specific for your organization. Okay. So then we get back to this motivating example. I just want to remind you of this example before we move on to NSM. How do we connect a web app to an on-prem database? Well, using Spire, you can get this identity that will allow you to establish your TLS tunnel or your application protocol credentials. NSM is about establishing that same connection at a lower level, at layer 3 or even layer 2. And I'm going to skip that. So just a quick summary, if you're interested in Spiffy and Spire, we've got a website, of course, we've got a Slack that I'm on constantly, a Twitter, we've got a book. This is actually available now. It's on the website. Frederick and I and many others co-authored.
Thank you. I just put up the poll question for closing that talk. So thanks for giving a feedback here. I think you guys answered all of the questions we had in the chat. I'm just gonna share a last slide and call it. This is just to remind you that if you want to join or check out what we do in the developer community, you can go check our new website. It was a lot of work, so we'd be happy to see you there on hpdev.io or developer.hp.com. We also publish a monthly newsletter. We'll drop the link in the links in the chat. Maybe Frederick can do that. We have a monthly newsletter that you can subscribe to. We also have a Twitter account and a couple of Yammer groups for partners and for internal folks, where you can join and keep up to date with what we provide. And finally, we also have a service called Workshops on Demand. We don't have anything yet on Spiffe Spire. We are working on this. These workshops are things you can book and run. They use Jupyter notebooks, and you can have this platform for 4 hours and do some labs, hands-on lab, any time of day or night or whatever. So check out, we have like 16 different workshops from programming Python to Rust to Esmeralda stuff, and hopefully soon we'll have Data Fabric and we'll have Spiffe Spire fundamentals. And so take a look at that. This scan code at the top lets you get to a web page where you have all the links as well. And with that, I would like to thank again Daniel and Frederick. That was a very great talk, and wish you a great rest of your day, and talk to you next month. Bye-bye.